Okay, I'm recording. Okay, so here we have the formulas. Suppose you're offered two jobs. Starting salary is 60,000 yearly, and we got a raise of $3,000. Job of B gives a starting salary of 65 thousand dollars, yearly raise of 6%. If you plan to work at this job for 5 years, which option will make the most total money over the years? So we got we use the arithmetic because every year we get in job A we get 3,000 more, and here we got 6% more. Wait, this in the job B, do we get the 6% of this amount or the 6% of every year? Like 6% plus on this, and then we take all the 6% and we do with every
I
year.
think it's two different ones.
Yeah.
Mm-hmm.
So yeah, we have to work out A and then B. So we'll get it from, oh, actually, I don't know. Well, it says yearly raise of 6%. So
Mhm.
each year it goes up 6%.
Okay. Yeah, but it's from the initial amount or if it's from the every year amount that we get. So if we get like let's say if this year I get $1 and the other year I get 1.6, do the 6% applies to this amount still, or now it applies to the new amount? So that's my question.
I think it there are two different um let's see.
I think it's just, oh, never mind.
I think it's a yearly, like let's say, yeah, like you said, you got $1 first and then they raise it the next year. And then from what you have, they raise it 6% the next year. Does that make sense?
Mm-hmm.
That's what at my job, they paid me something and then each year it goes up by something.
Okay.
But I think that's what it says. I think that's what it means, at least. I'm not sure though.
Okay, you have the.
Yeah, so basically there are two jobs here, right? There
Mm-hmm.
are two different jobs, and one of them they offer you a salary that starts at 60,000 per K, but every year they raised 3,000. And we have to figure it out how much are we gonna gain uh at the end of the year. And for the B is figure it out what that 6% is in numbers, and then the number like the letter A, it says after 5 years, which one of these two are the one that pay the most, maybe.
Okay.
And so it's kind of the same, but we have to figure it out with the 6%.
Okay.
Yeah. But I think the first one we just add it, right? So 60K, 63K, 66K, and then just add all of that at the end.
Mm-hmm.
And
Okay.
then the other one, I think it's a geometric system, and so we do it different.
Okay, so for the first one, you will have the sigma thing. Underneath it says the starting base number for
We
the index.
Yeah, for the sum we need to get the first will how is it called? What is the amount for the fifth year? Okay, so for the first year we got this, and then we got 3,672K. I guess someone correct me. This is a number 5.
Oh yeah, at the end that would be on year 5 it would be 72K, yeah.
Let me check. What was the formula? IN equals A1 plus -1 for D. Okay, A1 will be 60,000. This will be 4 because there are 5 years. 3,000. 12,000. 12,000. Yeah, it's 72K. Okay, so okay, now we need to sum. How we this is a sum. Into we got 5 over 5, 2, 6. Someone correct me. 6,000 plus 72. Something like that. Just so. That gave me 330K.
Yeah, that's what I got too.
Okay, Mateo, you can write down.
Yes, but what's the sorry, I got lost with the steps of solving the problem.
What?
I got lost with the steps of solving the problem. So
Oh.
do we have to put the sigma thing with the numbers?
I mean, wait, because I'm using the formula that I got. Mm,
Because there are like 3 formulas up.
yeah, I'm using this. Okay, this is like yes, this is for the sum, and this is for the value. So here, so we have 5 years. You replace this, and yeah, the I will be 1. Oh no, what?
It would be
I think yeah, the I is 1 because it's not the constant, but uh the number. So here's how many numbers do we have? 5 years, and this is I don't know how to explain it.
this is the year 1.
Yeah, something like that. Yes.
So underneath the sigma is the starting point, which is year 1, and it's gonna go up to 5 years, and that's gonna be the upper and the number.
Okay. Yeah. So you could replace
Oh,
like 60K plus K minus 1. This is it for the 5th year. 5 minus 1, and D will be 3,000. That is a raise.
so
We can.
He froze a little bit.
He
Okay, froze.
froze. Yeah. So I'm gonna pause for a moment.
okay.
Okay. Yeah. Okay. We're here again.
Great. So the question is the 60K, and then
Your
we just
for to know the value of our salary when we have worked for 5 years. So you replace the K minus one. Well, 5 minus 1. And the D will be the 3,000.
5 minus 1.
Mm, that multiplied for 3,000, and it will be equal to 72K.
And a D is a 3,000.
Yes.
Yes.
Okay. And it's going to be equals to 70.
72. And now we apply this formula to see the sum of the all or salaries during these 5 years. So we got n will be 5/2 open parenthesis
6,000 or 60,000.
60,000 and 72K.
So it's going to be, and it's the 5 years divided
Yeah.
by 2.
Yeah.
5 years divided by 2. And it's going to be 60,000 plus.
The 72,000.
Okay.
Okay.
Great.
Okay. And the answer is 330,000. Let me check again.
Yeah.
So that's for job A.
Yes.
Yep.
Okay.
Okay, so now for job B.
It's geometric, right?
Oh, I have low battery. I'll see my charger.
Okay, so we do the same Sigma thing where we can put all the information there, or what? How would you solve this one?
Mm,
Did she stop the recording?
no, I think she went to get her charger because it's gonna die.
Oh, okay.
It's still recording.
Okay.
Okay, I got it. For job B, the starting salary is 665.
Would this one be the SN equal to and then do the formula? Or did we use the same?
I think
Here.
it's geometric because every year goes adding up 6%.
So it's the SN equals A1, that one?
S equals, where is the geometric? It's, let me check the
Five.
formula.
The S with the little 5 on the lower end, right? Or no?
The S with what?
The S with the little 5 on the end because it's the 5 years. We don't use those formulas up here, right?
I'm using the ones that I got in Alex this is arithmetic, this is geometric, and this is for infinite geometric. I got confused.
Yeah, so
This is
we
oh,
don't use the third one because it is an infinite like series of numbers, and we don't have like just have 5 years from 1 to 5 years.
okay, okay. This is the sum to know a value. So we will use that first.
Okay.
Here this is the sum. I'm using my my notes. So to know the value, oh gosh.
So 65 is going to be the value, right? 65,000.
Here's A1. Okay. AR is the 0.06.
So times the rate,
Mm?
0.06 is 6% or is it 0.06?
0.06. Because it's the
Is that it 6% or is that 60%?
six.
0.06.
0.06. Okay.
Okay. What else? K will be 5 minus 1. It will be 4. Let me do the calculation. 0.065, 0.06. But what?
What did you get?
I got a decimal number. What?
I got 3,900, but I don't know if that's right.
For uh sure, sure. Yeah, the 6% will be um 3,900. Wait.
So do you want me to just switch the 0.06 for the result? 3,500?
I think, wait, 0.06.
No, because it takes actually 6% of everything that's gonna go the next year.
Okay.
So the
It
6% is gonna just increase
so
after every year.
it will be then 1.6, 1.06. I don't know if it makes sense because I was like taking because I got this number. So but here we got a different number. Well, it's a different sequence, um but if we take like 6% of every amount we get here, we get a lower number, so it doesn't make like sense.
So you said you think it's 1.6, 0.06?
Because it's we're taking the last amount we got,
Mm.
and we're summing this up.
So basically, it starts with K 1 year, but then plus one to just go 1, 1, 1 instead of K -1 -1.
I think it will be like K R will be 1.006. No, what I'm talking about, 06. So every year we're increasing 1.06.
So you would raise it to a certain power. So let's say for year two would be raised to the second power.
Uh, something like that, like here. Um, no, like it wouldn't be. It's not raised. Like this is the constant PR. So let's say if I have $1 and every year um I'm winning like 6%. I wouldn't, if I take the 6%, I will get like 0.06, but that's not the final amount that I'm getting. So the 6% will be like $1.6. So if that makes sense, 0.6. I don't know if it makes sense.
So we need to delete that 0.06 and put the 1.06.
So delete this one and put I got lost.
The 1.06, I think, in parentheses.
1.06 in parentheses.
Because in my head, it's like the 65K and then the parentheses of the 1.06. And that gives us a value of 68K. And then in the second year, or I mean, in the third year, we do it to the second power on the rate. Does that make sense?
So basically, that one is gonna be equal to, and then we raise it through the powers according to years.
Yeah, but the first year it stays the 65K because it's every other year. It's the next year. So the first year you get the 65 and then that's it like that. But then on the second year it's 65K times the 1.06, which gives us the amount. On the third year it's the 65K parentheses. But I think the power goes inside the parentheses. I don't know if that makes sense or not.
Second year we got this amount, and then we got the 4 plus 1.06. We get this amount.
Does that make sense? I don't know.
Yeah, and at the end, now we want to know.
And then at the end of all of those sums of those years, we do the geometric system. I think that's what, I don't know. That's just what I think though, but I don't know if it even makes sense. So
Oh my gosh, I got 82,
yeah, I mean,
82,000.
Edit.
I got it off. We got, so we summed that number. Okay, do we have to round the number, or because it's decimal, but it's exact, it's not infinite, so.
So 82,000 is for the first one, and then you add
82,000 is for the last year.
last year.
82,061.0024. That will be the exact amount.
Okay, 82,061. 61 cents.
82,061.
8261.
061.
I don't know why it is showing like that, but now it's being corrected. It says 61.
Okay, and 0 point, yeah, and 2 zeros, 24.
2024.
Yep.
So
Zero,
it's a
zero.
million.
Oh no, it's like it's, you put the point and it's
I think it's okay if we leave it like that.
Yeah, okay, nice.
Or we can do the second decimal, like,
00.
yeah, or just whatever if you want to round it. Just 82061. I think it's fine.
Okay. Now we got the sum. It will be A1, 5,000. I'm gonna put just K, 60K. 1 minus R is 1.065. That over 1 minus 1.06. The calculation. Okay. Stefan, I'm gonna delete this. 1 minus 1.06. I got 3,306. I got this number.
3,000 or 366,411. Yeah.
Yeah.
Wait. 3, wow,
366
366.
and then comma 411.
411.
Okay. So basically, in the which job should make the most money? I'm gonna
Okay, so uh we made more money on in job B.
Yeah.
So we're gonna put here. Oops. Job B. Okay, nice. If you plan to stay at this job for 50 years, does the answer, oh, let me delete this.
sorry.
It's okay.
Well, it's kind of slow.
It's okay. If you plan, oh my gosh. Oh my gosh. Okay, if you plan to stay at this job for 15 years, does your answer, we have to do the same thing.
Yeah, just instead of the 5, do the 15.
Uh-huh. Okay, you can start writing the same formula. Here you put 15 and here 15 over 2, and then we get, I can do the first
Okay, I'll do the second
equation.
one.
So the question is, could you please give more space down for the B so I can write?
Sure.
Thank you.
Okay. I'm gonna do, I can do job A.
Okay, I'll do the second one.
Okay. So you replace the values. Just instead
Just
of
the year, really. So, right?
Mm,
60,000, 15 minus 1, 3,000. Oh, I got a lot of Zero. Thousand. Oh, plus. Okay, for the answer in the first one will be 102,000 for the value 15.
Wait, so it's gonna be one. Wait, it's gonna be for the first one, right?
For job A, the
102.
102 and 3 zeros. Now let me do the
102,000, 100,000.
Yep.
I
Like that.
got for that one, I got 1,500.
Wait, are we talking this in the same
No,
one or the one below?
yeah, the one below.
So one.
5,
Mm-hmm.
and then another 5,776.
Okay.
So 155,776.
Uh-huh.
Okay. For the sum, I got 1,000,000 two, okay, 1215000. 1 2.
1,500. Like that?
Oh, no, it's for the sum, not for the in the sum you have to put the same value as here because
Oh
you're
yeah.
yeah.
But is that the number?
It's 1215001.
Can you tell me like one is 1 million, right?
1,215,000. I will basically like that. And here your place value.
1215000.
Uh-huh.
Okay.
Let me know when you're ready for mine.
Okay. And yeah, we are there. Let me, what else? We have to do the division and put the 65
Yeah, and then
here. It's gonna be one negative 1.06, right? And by 15, and 1 minus 1.06. That's going to be equals to
1,512,938. So 1,512 and
mhm,
then 938.04.
0.04. Okay, I don't know why is that it's taking longer than expected, but it should be on its way.
Oh, okay.
Um, right.
Okay, so job B still makes a lot more money.
Yeah,
And then write that down.
okay. Let's try to do this pretty fast. The multiplier effect is the idea that when one person spends money, the responsible person.
Next, suppose that 200 million is spent annually, but first when it is spent the first time.
Oh.
So the initial value is gonna be 200 million, right? Represents which term? So this represents B1 in the series
Okay.
or A1.
This represent which term? Yeah, A1. Then the next term is the series is the so 75%, so it will be one 150. Oh, someone correct me.
What was the question for? This was mm,
Uh,
yeah,
then
100.
150 million. Again, the next term is a 75%. That will be 125. No, someone correct me.
It's gonna be
Yeah, I know 112. Sorry, my bad. 112.5.
Yeah.
and then the
Or
75% of that one. Is this an Arabic or geometric series?
It's yeah, it's geometric. Because I'm gonna write here. It's geometric because we're multiplying. Well, we're dividing instead of.
Do you want me to write that or you are gonna write it?
I can do it.
It's that one is actually
Oh,
because I already did one, but
okay. Let me delete it.
whatever you want.
Yeah.
I don't know why it takes longer to.
because we're multiplying each term by 0.7, right? 0.75.
Mhm.
Fine. Which value of 12 constant every year. Does this scenario represent a partial sum or an infinite sum?
An infinite
It will
because
be
it's never gonna finish, but you continue.
choose from the following summations formula top to find the total amount spent. Theoretical amount spent. Total amount spent from the initial 2 million. It will be, I think it's the infinite because they're not giving us any value. Like, I'll calculate this in the past 10 years or 12 years, or they're not giving us a time. They're just saying calculate it. That's my guess.
Yeah.
See.
Um, okay. So the sum will be A1, that is 2 million, 200 million over 1 minus 0.75.
So that one is for H.
Yes, it's this one. A1 over 1 minus R. Yep, for the infinite number. So we replace here 2 million, 1 minus, 0.75 or 3/4, the way you want to put it.
That let's see. So it's 200 million. Where?
Oh, this is for the
200,
this is for now the value, but now let's use this one. A1 200
201, and the rate is 0.75.
Yes. I think this was the easiest one.
Hmm?
I think this was the easiest one. We got it quick.
Yeah, it's loading.
Okay. Let me do the calculation.
Sorry, come on.
I got 800.
20 million, 200 million. But
Oh, I think I did something wrong. Because I put it in again and I got 199, but it's probably wrong.
So the theoretical amount is
I got
199.
No, hold on.
got
So
a I got a bigger number.
what did you get?
I got a 800.
Yeah, that's what I got first, but I'm not sure how I got that.
I don't know if okay.
I redid it again and I just got 199.
Mm,
Did you divide it by a different one?
I divided by 0.25.
Oh, okay. Yeah, I think that's what I missed on the second time we did it. So it's 800.
Okay. 800 million. Oh, we've got a bigger number here.
Give me give me 800 here.
Um, You're
Oh,
already spent. Oh, do you want me to delete it or you already reading?
I already did it, but it just takes time. I don't know why.
Okay, let's go to this one. First Christ fraction with denominator 10.
Do we just divide on there as well?
Yeah.
Um, First grade 0.4 as a fraction with denominator 10. It will be just
0.4 over 10,
yeah.
like a division.
Uh, Sorry, this is kind of slow. I don't know why.
It's okay. Okay. Oh, it will be just 4, not the 0.
It's just gonna be 4.
Yeah, 4 over 10. That's it.
How about the 0.4?
It will be 4 over 100, and in this it will be 4 over 1,000.
1,000.
And it's geometric, right? Because we're dividing again.
Yeah. We're dividing 10. It's per the factor will be 10. Okay.
Divide.
Wait. What type of series? Geometric. A1 and R for the series. To show how this work. Wait, what? We are dividing by factors of the
right?
yeah, identify A1.
Would it be the
And
410?
Wait,
Four
wait,
over
mhm.
per 10. Wait. Per 10 will be like 0.410 will give us. Huh.
I think he deleted it. It just sticks to Y.
Yeah, it's been deleted, but it's
It's
just
good.
funky because
Yeah, because if we multiply it by 10, this will be just 4. And if we multiply it by 10, this will be like 0.4.
10.
Wait, I got kind of confused. Never mind. A1 and R for the series will be
Would the common ratio be 1 over 10?
1 over, yeah. Oh yeah, because we have a fraction, so 1 over 10 will be the
1
um
1 over 10, you say?
Mhm.
1 over 10.
is the correct formula. Oh, but no, you can also keep the 4 over 10. Just put
So
A1
A, mhm.
A1 equals and R equals.
The A1 is the 4 over 10. Yeah.
A1, comma, okay. Mm-hmm. A2. Okay. The A1 looks amazing here, but it's gonna take a while.
Okay, let me. Um,
So we just choose from the top 3 formulas, right? To know how to do that.
yeah, find the fraction form of the repeating decimal of 0. If this is an infinite number,
Would it be the middle one?
it's like an infinite. So no,
Oh,
no. Oh my gosh, I got confused. Right here.
Yeah, it's gonna be the middle one because the top number is gonna be 1,000, right? So it's going to be 1, 2, 3,
Because
actually 3 times 10.
I don't know, but in high school, I learned, I don't know if someone correct me, that the infinite numbers like they go over 9 or over, like let's say over 9 or over 99 or over 90 or something like that.
I don't know. I don't remember that.
Wait, let me check.
But you could be right.
Numbers fraction. Because it was something like
Yeah. Do you guys think it's the infinite geometric series? Since the numbers keep going on forever, or the middle one?
Uh, having fun.
I think it might be the infinite because just the numbers just keep going forever.
Keep going forever. Well, let's do that one. Because it's the correct formula to first patch to find the fraction of it. Yeah, it's the infinite one because we're not using the previous ones uh, here, but so okay equals 1. And gonna go
And it would equals to 1/10. No, 4/10. And then 1 minus
so
1/10.
equals 4/10.
Yeah,
Wait,
because the A1.
so 4/10 is gonna be on the numerator altogether.
Something like
Yeah.
okay, I found
Yeah.
an image. So I don't know if you guys can see. Like so because the 4 repeats like multiple times, it goes over 9. I don't know, but I learned this in high school, just like I cannot remember well.
So okay. The formula has like a fraction, and you say that I have to put 1/9 in this case. It's gonna be 1/9 in the numerator.
Mm,
Yeah, the whole fraction is it's gonna be like 3 fractions kind of.
So the whole fraction would be 1/9. And well, it's gonna be deleted in 1 sec. But like that,
Wouldn't
the
it be,
the
sorry,
4 is deleted. I don't know why it is still there, the 4, but it's 1/9.
I'm just confused because why would we use those if like the A1 is the 410? I'm confused on that.
oh, I got an image here. That's it. Repeating decimal 0.4. The fraction will be 4/9. I don't know if you guys are saying.
So it would be 4/9 then?
Yep, because can be represented like 4.
But that would be the last answer, right? Or
From
are you
will be
saying add it?
that will be like the decimal what I'm talking about, the fraction. But we can for 1 minus how much was our
I
was
think we should just use whatever it's giving us here, right? Like the 4/10 and see what it gives us. If it doesn't
okay.
give us the right answer, just try what you're saying.
Okay. Okay, so it will be
The 4/10.
1 minus 1/10.
Mhm.
One, 1/10.
And on the top, it would be 4/10, right?
Like so. I'm gonna put it here.
No, but that I think that 4 is gonna be deleted later. Because in
Okay.
mine it doesn't exist. I deleted it
Okay.
just in case. But you can delete the 4 just in case it done messed up.
Okay. Let's put it um for 10. So how much is 0.9 for 10? 0.4. 0.4. Oh my gosh, I'm not writing with this thing. 0.4 over.
Yeah.
Oh, wait.
0.44444444. That's the answer. I don't know.
Find the fraction. Okay, we need to find the fraction.
Which would be the 4/9, I think, of what you were saying from that picture that you showed us.
Mhm.
It's going 0.444. The fraction would be 4/9, I think.
4/9.
Okay.
Does that make sense?
Mm-hmm.
Mm-hmm.
That picture that you showed us was helpful because that is a fraction of the 0.4 infinite.
Okay. Okay, then we go. Okay, this one. I recall that if $P is invested at our rate compound. Okay, we got 2 more pages to go. Oh, 3.
Okay. So we just rewrite the formula, right? So basically 100. So A equals, oh my. Por favor. A equals $1,000. Open parentheses 1 plus the 2%, which is 0.02, and times, it's gonna be 3. No, for 4 years interest rate. At the end of 4 years, you want to know your total amount. So yeah, it's gonna be 4 years because we just wanna know the amount. So 1,001 plus.
Do the calculation.
Hmm?
1.02.
So it gives me 1,082 with
Yep.
43
Yep.
cents.
Okay.
Great. The first amount you deposit amount earns 2% in interest until you pull it out at the end of the 4 years. You don't make interest for the first year since you put in at the end of the year. So how many years do you earn interest on your first 1,000? 3 years.
Yeah.
Okay. This means that the amount of the initial deposit becomes the future value. Could be written as
I got a question.
mhm.
The money invested for a year. The money invested at the 4 year will not earn any interest. Like, does that mean that we don't get any extra money from that?
For the 4 years.
Uh-huh.
Well, the first question is well, suppose that you invest year for
4 years.
1,000 a year for
Okay. Okay, let's go.
Okay, so if you, so I think the number one has to be changed, right? Because it says, suppose you invest 1,000 a year for 4 years. So every year is gonna be 1,000, right?
Uh-huh.
So the first year we have that, and the second year we have to sum this 1,082.43 plus 1,000 more for the second year. And at the end of the year, we add the 2% of that investment. Because I think in question one is just asking about in the period of 4 years, if you invest 1,000 each year, how much is gonna be, right? I don't know if it does make sense. So
Mm.
for year one, let me see. So this is gonna be year one, but year two is gonna be 1,082.43 one plus 0.02. No, wait a minute. I am now confused
Oh,
because it doesn't make any sense if we do it that way. I think we are right with the first answer
okay.
because we are doing it for the 4 years, but we are doing the $1,000 flat.
Okay.
That's the part that gets me confused about the question. You invest $1,000
Oh, okay. That makes sense.
every year, right?
Do
Uh-huh.
we have to solve anything for that first one?
Excuse me?
Do we have to solve anything for that first one? I think it's just letting us know. I don't know.
Okay. Could you explain more? Because
I'm just saying, like on the where it says four,
uh-huh.
oh, I guess you're looking for the total amount of what it would be after the 4 years.
Yes, if
Oh,
each year we put $1,000. So suppose you invest $1,000 a year for 4 years.
okay.
I don't know, because this is my second language, so I get confused by the tongue twister here. So for my understanding, every year we're gonna put $1,000. Is that right or not?
Mm-hmm. Yeah.
So so we have to find the 2% for first year instead of those four. So here is gonna be one instead of four. Let's see. So it's 1,000.
Because here it's mentioned that the first year will earn 3 years of interest rate. So we got 4 years, but 3 years of that rate. And then we got the second year, we will earn interested for 2 years. So we got
Mm.
oh wait, okay, makes sense, makes sense.
So the first year for my calculation is gonna be 1,020. So the first year you're gonna add that's 1,020 plus $1,000 of the second year.
Mm.
I don't know why it looks like that. And then you have to add
Okay, makes
it's
sense.
it's equals to 1,020
Okay, I got it, got it, got it.
plus 1,000 1 plus 0.02. So how much is 2020 plus?
Yes, yes.
No.
Oh, here it gave us the formulas, like,
Yeah.
okay,
Well, that's another way to do it too.
okay, 1, 3, 2, 1, and we got here 4 years.
Yeah, but you have to get the result. Oh, it does it give us the result or not?
That's like, at the end of your deposit will last, wait, how many? 1, 2, 3, 4. 1, 2, 3, 4. At the end of the 4th year, you deposit the last 1,000 and then calculate. So this will be like the 4th year. And here it's like at the end of the 3rd year, you deposit 1,000 again. What?
60.4 year two.
Oh. Which one are you doing now?
The first one.
Okay.
So basically, it's taking the result of year one and then added it to the $1,000 that we're doing for year two, doing the calculation for the percentage, and the year two is gonna have this amount that is added. The money that we have for year one plus the uh interest rate that we won for second year plus
But
the deposit we did.
that's in the B and C, right? Like the
BNC? What do you
uh-huh.
mean?
Like that's what we do in the next problems. Like if
This means that the amount of initial deposit becomes the future. But the thing is that the B, it says at the end of year two, you deposit another 1,000. So in this case, the number one doesn't tell us when you make the deposits. Here they tell us like the deposits each year, so you don't actually get the money for the second year because you made the deposit at the end of the year. But no, that's the tricky question with number four, the first one, because it doesn't say like it is at the end or it is at, or maybe number four is just like part of the question, and then you respond like answer A, B,
yeah,
and C.
that's what I was
I think,
thinking.
yeah, I think it's a prompt because number 2, number 1, suppose you are offered 2 jobs.
Yeah,
I think
I think it's just letting us know.
Oh, I don't know, because there is like a space there, so I thought we have to answer how much if you invest every year, how much you.
okay,
Oh,
suppose
we can leave the logic there, and she will notice. I can finish that later, so
okay.
she can notice that we know understand what's the.
I think the first part like this one it's
Be right
okay,
back.
but the other ones are like extra, but the A will be like okay. So I think we got to
3 years.
here. Yeah. First amount you deposit amount turns. So how many years do you earn interest on your first? You don't make interest for the first year.
Mm-mm.
You put it at the end of the year. How many years do you earn? Okay, 3 years.
Yep.
Okay. The, this means the amount of the initial deposit becomes could be written as okay. P1 plus R. How much was R?
So it would be 1,000, right?
0.2.
2.
Okay. Okay, this is for years you're interested. Okay. At the end of year 2, so the first year we didn't got interest. The second one we got it. You deposit another 1,000.
Basically, it
is-
would be
What is it?
1,000
How many years will this earn interest? Oh my gosh.
in 2 years. Well, so I think it's gonna be like this. Let's see if it for 2 years. Because if we are putting the money at the end of year 2, it means the interest is gonna cover year 3 and 4,
Okay.
where it
Mm,
is $1,000. So the total interest we gain about in this investment is doing the calculation of 1,000 parentheses 1 plus 0.02. $1,020 is gonna be
One.
no. And I have to do that. I did it wrong. I forgot about the power of 2.
It gave.
1,000 open parentheses
I got.
plus 1. Mm-hmm.
Yep. I just said.
2 close power of 2. 1,040.
Four.
1,040.4. Yeah.
Okay.
So this is the answer, I believe. At the end of year 3, you deposit 1,000 again. What is the future value of this deposit? So it's kind of the same thing, but 1,000 dollars, 1 plus 0.02, and this one is not elevated because it's just 1 year. It's gonna be 120.
Would it be elevated to the first power or no?
But it's gonna be the same
Oh,
if you
okay.
elevate it at the
That's
first
true.
power.
Okay.
The,
So I don't know if you guys have the same number.
yeah, I got it here.
Great.
Okay.
At
Um,
the end of year 4, deposit.
um, and then calculate. Okay, so this was
So
uh
basically, we don't, the amount is the same. So we have to sum all of them, which is 1,020 plus 140, right?
someone can do the
I can do it.
okay. We're multiplying each factor. Okay. Use it correct to find the total. The total will
Wait,
be will be
I'll go last.
I think it will be easier if we sum up the numbers. Oh my gosh.
It would be number 1,
It
or you say that's number 2,
number it will be this one because
the
it's
middle one.
you yeah because it's geometric. It will be yeah this A1 parentheses 1 minus R or N. So A1 will be how much do we got in A1?
Um, I'm doing the
A1 is just $1,000.
Okay. Mm.
Okay, so basically number of years is 4. Um, K. This gonna start with 1.
A1.
I got the sum of all of that, like on the thing, is 6,768.4.
Let me check. How much?
6,768.4.
Give me a minute. Four.
So it's gonna be equals what's the value of A?
I got for 4,121.
Wait, I just got lost. Um, so for this Sigma, it's 4,000,
What if we
or are we talking about the value of A?
uh, I I think it's the sum. It will be easier if we would just, because we have the formula here and we have the values. So it will be
Mhm.
one two. I'm gonna do it that way because we don't have a lot of values. 1,000 plus
Wouldn't A1 be 1,000?
20. What?
A1?
It's
It
gonna
will-
be 1,000.
Okay. For the three values, I got 3,064, and for the last one, I got 1.02.
The thing that we can do is
Yeah.
simple. The first year we don't have any revenue. We just have the 1,000, right? I'm
Mhm.
gonna do 1,000 times 4 because each year we put like $4,000. But the first one we didn't claim. The first year we don't have interest rate, right? But the second year we have 40. How much money? 40. 40.4 of interest rate. And the third year we have 20. So it's gonna be 4,060.4 for me. The $1,000 that we put each year and plus the interest rate that we gain each year. The number four, we didn't get interest rate. Number one, we didn't get interest rate, but we got interest rate for $20, the difference for year three, and 40.2 for year two. That's my logic, but I don't know if works. I don't know.
What I will do is just sum this up because we don't have a lot of values, and I think it will be easier. And then we
That's
can
what I got when I summed it up. It was 6,768. But let me know what you get. Let's see.
I got 4,021,
Okay,
608.
that's fine. Okay.
Mm,
So would that be E?
let me check again just in case, but this time with my calculator. 1.02. 1,000. 1.02 over 2. 1,000. 0.023. I still got there.
Okay.
But someone can check again just in case.
I can do it again. Maybe I did something wrong.
Check into.
Yeah, I got 4,121. Is that what you got?
Mm-hmm. 608.
Yeah.
Okay, this will be for.
I think I forgot to put a decimal.
Oh my gosh, for 4. Wait. In 4. Um, um, okay. How much do you got, Mateo?
4,121.60.
Okay. Does it appear on your document? Because I'm using the.
No yet.
Okay, let's wait. Mm,
It's not there.
okay. No, this graphic might help you understand. Yeah, okay, this is our last one. Mm, extending one more steps. Suppose that the P dollars is invested at the end of the year. If you deposit each month into annuity. So the rate this time will be 0.068.
60 or 58.
60, I'm sorry, 58. Yeah. And what is the
Monthly, so it's gonna be divided by 12, right? Or not? I
um
don't remember which
yeah, each month I think it was, oh yeah, good catch. Each month. Yeah, it will be 12.
12 and the time is 41 years. But I don't remember if the 12 is gonna be on the power of n and then 40 times 48 years, or what is gonna be that end on the fraction. I don't know.
Like here.
I think it's 12. Right there when you're pointing is 12 times 40 in the years. How many?
Well,
40
we
something
have
years?
we have to put it, yeah, with 65, 20, 42 years. Yeah, we have to put it as months. How much
Yeah.
is? Let
Do
me.
we put it on the power or what? We have two ends. I don't remember where to put the
I would
12
put it on both because they're the
on
same.
both.
500 of 504
12 and so
and the power. Yep.
12 times 42
Two, which
years.
is 504.
And everything is gonna be divided by 0.058 over 12. So this one we can cancel. I don't know if it is like, but we can cancel the fraction in the denominator with the fraction in the numerator, right? Or not?
I don't think so because here we can cancel it if it's a multiplication like this, but it's a sum.
Uh,
I don't think we can't.
Okay, I can, let's see.
So basically, let's take the answer for the top
Mm,
and divide it by the answer by the bottom. Bottom.
0.58, 12. Um,
And I forgot the -1.
-1. I got 124,012.
Let's see. I am doing the 12 times 42.
I got an answer, but I don't think it's correct because it's too high.
-1. Wait, how much did you get?
I got 1,024. Yeah, no, 124,012.
Well, let's use that one because mine gives me, for some reason, gives me 0.
How much do you got, Scarlett?
I got, it was like in the 4,000, so I don't think mine is correct.
Okay, let's use that one. So 100, wait, 1 comma, no, 1, what? Sorry.
Oh my gosh, wait. Oh, I put a number, but no, I got another number because here I put over 15, but I realized I put with 12. I got, oh gosh, this number 2000, no, 214,352, and I got like a bunch of decimals. It will
What
be
are the
214,352.698. Let's put it 70
70?
because instead of
And that
69 because it's a decimal.
Okay, and you got the whole answer for the fraction that we had, or we still have to divide that by the other fraction.
Oh, no, 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 that's like the whole thing.
Okay.
I think that's all that we have to do.
Yay.
Yes.
Okay. Amazing.
Good job, everybody.
Okay,
Boys.
I'm gonna stop recording. Thank you for being here. Stop recording.